This is a review for Unit 5. Let's start off by graphing points. So first of all, this horizontal axis is the x-axis. This vertical axis is the y-axis. You always start at the origin, 0, 0, and you count over how many to the right, that's 2, and how many up, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your point 2, 9. For B, we're going 5 to the left and 4 up. C goes 3 to the left and 2 down. D goes 4 to the right and 7 up. E goes 8 to the right and 6 down. And F goes not to the left or right at all, and then down 8. So for x, we think of plus and minus, and for y, we think of plus and minus, and it always starts at the origin. These coordinates are listed as x, comma, y. For quadrants, this is Q1, Q2, Q3, and Q4. So points A and D are here in Q1. Point B is in Q2. Point C is in Q3. Point E is in Q4. And for F, we can say this is on the y-axis. That's what this is called. It's the y-axis. And similarly, this one would be called the x-axis. If points are on those lines, they're not in any particular quadrant. They're on the x or the y-axis. Sometimes students get confused with the zeros. Remember, this is 4, 0 here. And -3, -1 right there. -1, 5. And 0, -4. In these mapping diagrams, to write them as coordinates, you write 3, -1, or 6, 4, or 8, 4, or -1, 3, or 4, 6, or 4, 8. These are like the x coordinates, these are like the y, and each arrow represents a coordinate. The domain is left to right. So the leftmost point is here, and the rightmost point is here. So if we put x in the middle, we know that it's going to be -4 to a +4. For range, that's bottom to top. So the bottommost point on this graph is here, and the topmost point is here. So if I put y in the middle for range, the lowest here is going to be -3, and the highest is going to be a +4. Range is all the possible y values, and you don't repeat. So you could write the range as these 3 coordinates. Now you don't need to put parentheses, you could just list them like this, just don't repeat. For the domain, we tend to write from smallest to largest, so I'm going to rearrange the order a little bit, like this. Remember that domain is looking at only the x values, whereas range was looking at only the y values. How do you know if it's a function or not? You're going to look at the x values, see if any repeat. This one, the answer is no. Again, no. Here we see some repeats. 5 shows up as the x value 3 times for function h. And notice they have different y values, so that makes it not a function. The same thing is true here for j. 3 shows up twice with different y values. Notice that the y values can repeat for functions, and technically the x values could repeat. It's just that every single y value would have to be the same. Graphically, you're looking to pass the vertical line test. If you put a vertical line from left to right, does it ever touch the graph more than once? Here, this one is not a function, because it fails the vertical line test. This one over here is a function. We look at the x values. -1 repeats, and they have different y values, so not a function. If you wanted to answer y, you could say -1 is mapped to different values, different y values. And if it was truly a function, it would be the same every time. This one is a function. Every single x has a unique y, or it has the same y every time. Every input has a consistent output. It doesn't matter that I see 4 here twice. For whatever the rule is, I'm following it because 6 gives me 4 and 8 gives me 4. This one, the number of teachers, is the independent variable. And based on that, we order a different amount of desks. For this one, the number of school lunches is the independent variable, and the dependent variable is the cost. Depending on how many school lunches you buy, it'll be a different amount. To find f of negative 20, that means we plug in and we say that f of x is equal to 20 over 5 plus 7. Well, 20 divided by 5 is 4, so this is the same thing as 4 plus 7, which is the same thing as 11. You can also put this into y equals and check the table. In this function, we plug in negative 9 for x, and f of x is equal to 8 minus 2 times negative 9 squared. If we do the order operations, we have 8 minus 2 times 81, or 8 minus 162, or negative 154. On a graph, if you're looking for negative 2, remember that these are the x values that we're plugging in. So we're going to look somewhere on this x-axis for a negative 2 and follow up, and what is the output? That's a positive 2. For 0, we're going to follow down, and the output is a negative 2. And for 1, we're going to follow down, and the output is a negative 1. Vertical line test, not a function. Vertical line test, this is a function. Vertical line test, not a function. Vertical line test, this is a function. Notice that none of the x values repeat. Function. The x values repeat with different y values, not a function. Though the x values all repeat, they have the same y value. So that works. And here none of the x values repeat, only the outputs repeat, which is fine. That can be a function. To evaluate this one, we can plug in a 7, so this becomes 3 times 7 minus 12, or 21 minus 12, which is 9. This becomes 2 times negative 2 squared plus 1. Negative 2 squared is 4, times 2 is 8, plus 1 is 9. This becomes 2 to the 5th minus 25. So 2 times 2 times 2 times 2 times 2, which is 32, minus 25 is 7. With this one, we're plugging in 2x, so this becomes 2 times 2x plus 4. This becomes 4x plus 4. Those are not like terms, so that's the most we can simplify things. On this graph, to find f of 2, remember that's your x, so we look here on the x-axis, and we follow down to see our output, which is negative 4. If negative 7 is our x value, we follow up, and we look for our output, which is 8. 3 vacation days for every month worked. This is the months worked, and down here is the vacation days. It depends how long you've worked. We can write this one as f of x is equal to, and notice that the per hour goes with the $1.25. So as the number of hours changes, 1.25 changes. That tells you it should be with the x. And the $3.50 is a one-time charge, that should be all by itself. If you want to know if these are on the graph, you can plug in a 4 for x, look at the table, see what your y value should be. If x is 4, y should be 46, so this one is not, because 446 is on the graph, but not 444. If I plug a 3 in, that gives me 3 squared, which is 9, times 3 is 27, minus 2 is 25. So this one is not on the graph either. If I plug a 2 in here, 2 times 1/4 is 1/2, minus 3 is negative 2.5, not on the graph. If I plug in a 4, That's 1 minus 3 is negative 2. This one is on the graph. To graph each of these, what I can do is solve them for y. So this one is going to be y is equal to negative x plus 5. And this one would be y is equal to negative x. And the rest are already solved. I can plug these into y equals on a calculator and press graph and compare the pictures. Here we have y is equal to 2x plus 3. Here we have y is equal to the absolute value of x plus 3. Here we have y is equal to negative x squared minus 3. This one is x plus y equals 0, or in other words, y is equal to negative x. This one is y is equal to the absolute value of x minus 3. This one is equal to y is equal to x squared minus 3. This one is x plus y is equal to 5, or y is equal to negative x plus 5. And this one is y is equal to 2x minus 3. So I'm going to put this function into y equals, and I'm going to press second graph and look at the table. And I'm looking for these values, negative 1 for x. What do I get for y? The answer is 0. For 0, what do I get? That's a negative 1. For 1, I get a 0. For 2, I get a 1. And for 3, I get a 2. So this is what my graph looks like. And if I was to finish the shape, it looks like this. If I do a similar thing for x squared minus 3, I have to pick my domain. So let's say I pick negative 2, negative 1, 0, 1, and 2. If I plug in these different values, I get these coordinates. And if I start to plot them, it looks like this, which is going to be this parabola looking thing. So if I see 0.5x and I start plugging in some different numbers, 0 will go here, 2 will go here, 4, 6, 8, and 10, and this is my line. They want to know, in 3.5 hours, how many miles. So I'm going to go here to 3.5, and I can estimate that at about a little less than 2, maybe 1.75.